beast, I'm a mobster. You got 50 whole bed, you'll be my sponsor. Them snakes on the plane, me and Kanye Conda. Yeah.
And for number 3, we want to solve the system x prime equals ax for a equals 2, 0, 0, negative 6, 2, 3, and 6, 0, 1. So, same procedure. We look at a minus lambda I, which is 2 minus lambda, negative 6, 6, 0, 2, 0, and 0, 3, negative 1. And sorry, I forgot the minus lambdas. We look at the determinant of this, and if we expand across the top, we just find that this is equal to 2 minus lambda times the determinant of 2 minus lambda, 0, 3, and negative 1 minus lambda. Expanding the second determinant out, we get 2 minus lambda times negative 1 minus lambda. And we set this equal to 0, so that gives us eigenvalues of 2 repeated twice, and negative 1. So let's deal with our eigenvalue of algebraic multiplicity 1, which is negative 1. So that means we consider a plus I, which is 3, 0, 0, negative 6, 3, 3, and 6, 0, 0. For looking for v1, which equals abc, that satisfies a plus I times v1 equals 0. We just look at the augmented matrix. Given here. Row reducing this gives us 3, 0, 0, a 1, 0, 0, and 0, 1, 1, and 0, 0, 0. So that tells us A equals 0, and then B plus C equals 0, or A equals 0, B equals negative C, and C equals C. So it means V1 equals 0, negative CC, or if C equals 1, 0, negative 1, 1. So that gives us one solution. x1 equals e to the negative t, 0, negative 1, 1. So now we go to our repeat eigenvalue, which is 2. So lambda 2 and 3 equal 2. And that means you have to consider a minus 2i. So this is equal to 0, 0, 0, negative 6, 0, 3, and 6, 0, 3. Oh, negative 3 there. And this better have a null space of dimension 2 to ensure that we have 2 eigenvectors, or that the geometric multiplicity of this eigenvalue is equal to the algebraic multiplicity, which is 2. So that means we need vector v, we'll call it v2 and 3, which equals d, e, f. And this has to satisfy a minus 2i, v2, 3 equaling 0. So this gives us the augmented matrix. That looks like that. Row reducing this gives us 2, 0, negative 1, 0, 0, 0, and 0, 0, 0. And that gives us 2d minus f equals 0, and that e equals e, and f equals f, or d equals f over 2, e equals e, and f equals f. So that means our v2, 3 equals f over 2, e, and f. We split this up based on components based on f and e. We get f over 2, 0, and f. plus 0e0. And if we factor out f from this, we see we have two free variables, f and e. Factoring out e, you get 0, 1, 0. So we have two free variables, and the things multiplied to these free variables are our eigenvectors, or the basis of the eigenspace of A, or the null space of A minus lambda I. So that means V2 is equal to a scalar multiple of this. We'll just multiply this by 2, so we get 1, 0, 2. And V3 equals a scalar multiple of that. We'll just use 0, 1, 0. And that means our x2 equals e to the 2t times 1, 0, 2. And x3 equals e to the 2t times 0, 1, 0. So that means our total solution, x equals c1 e to the negative t 0, negative 1, 1, plus c2 e to the 2t 1, 0, 2, plus c3 e to the 2t 0, 1, 0.
We please.
Yeah, overseas nigga. Top flow, clear windows, nigga. Glass house.